Morning students, last section we have studied about elevation, relative lowering of vapor pressure. Now let's see the second colligative property, that is called elevation in a boiling point. First of all, let us understand what is the boiling point. As we know all about, the boiling point means what? The temperature at which a liquid starts boiling. Okay, liquid starts boiling or converting into the uh, liquid to the gaseous state. That is what it is called. But what we define here now, after knowing the vapor pressure, we know that boiling point is the temperature at which its vapor pressure, the vapor pressure becomes equal to 180 m. That is what we called it as its boiling point. So here TB naught is a boiling point. It's a boiling point, okay, of what? So exactly a pure solvent. It's about pure solvent. So here you can see from the graph, okay, TB naught is the temperature at which the pure solvent becomes 1 degree Celsius, okay, or 180 m pressure. It will become 180 m pressure. So that is the temperature. It's called a boiling point. It's called its boiling point. But when we add a non-volatile solute, non-volatile solute, but obvious, the boiling point decreases. Why does it decrease? Because the vapor pressure also decreases, and when a vapor pressure decreases, what exactly we have to increase the temperature. So in the solution you can see the graph CD. What happened now? At this temperature it has to be, when it comes to this temperature, okay, it comes over here, but still it has to go there. Why? Because it is not 180 m. So I increases this, and then it comes that this one TB. This is what the boiling point. It's a boiling point, okay, of solution. So guys, what happened exactly? The boiling point increases, the boiling point of vapor pressure increases. So this is what the boiling point of a solution increases as the solute is added. So what happened? The pure solvent, the change in a temperature, and this is what exactly called elevation. It's called delta T, and the delta T is called elevation in a boiling point. Elevation in boiling point. So guys, this is what we have to study. So how can we use this thing? So it's very simple. So delta T, this can be used to identify what we can identify here. We can use this formula. With the help of such a formula, we can find out the molecular mass. So this is called the boiling point, elevation in a boiling point. So what exactly happened? This temperature pressure, so change in a boiling point is delta TB. I can write down as a delta TB, means it's a temperature elevation in a boiling point given by, it's always greater, TB is always greater than T naught B. T naught B is the boiling point of a pure solvent. It's a boiling point of a pure solvent where TB is always greater than T naught B. So this is what it's called a change in a temperature. So this is the temperature which comes over here. Now we understand this thing, the atmospheric vapor pressure of a solution at TB, okay, T naught B is much less than the atmospheric. Therefore it is necessary to a solution to go for higher temperature. So what is it called? This depends. Now the sum of the magnitude, it depends on delta TB is directly proportional, or you can say it depends on molarity. Okay, it depends on the vapor pressure as well. It depends on the vapor pressure as well. So what is it? It depends on the lowering of vapor pressure. So directly depend on the delta P. And as we know, according to the Raoult's law, delta P is what? According to Raoult's law, delta P is it is x of P. Yeah, in the previous section we have seen it's a mole fraction. So according to this, delta TB is directly proportional to XB. Okay, now what is XB? To remove this proportionality sign, we use 1K, a constant. Okay, now this constant, we called it as something different. What is it? Let us understand this. So K, what is K? K is a constant, that is XB. Now XB is a mole fraction of solute. So how can I write down that mole fraction of a solute is like this: NB upon Na plus NB, where we are going to neglect this value. What is the way we are going to, for the dilute solution, for dilute solution, NB is very less than Na. So it's neglected. So it's neglected from denominator. Okay, I'm showing you this very simply. How does this come? That is what I'm showing you. It's a, which is not necessary to write down for the examination purpose, but for understanding this is very important. So NB upon Na, and as you know guys, NB upon Na એટલે શું આપણને તો already ખબર છે, number of moles. So can I write down like this way, WB upon MB divided by WA upon MA. Okay, so what is that? In a book it is given 1 and 2. I am taking A and B. A for solvent and B for solute. I'm always writing whenever I'm writing this, because this is what I'm taking. You can take 1 and 2 as well. Okay, 2 for the solute and 1 for the solvent. What is that? So now delta TB. So what can I write down in this way? Delta WB into MA, because molecular mass of this is going to be up, divided by, what is it? This is WA into MB, because denominator, numerator's denominator will be denominator will be numerator. So we can write it down in this way, and that's what we can write it down over here. Okay, so now what is it exactly? This is what I can write down. So what WA mass, let us understand this manner in this way. NB can be captured like this, NB. Okay, this. Now MA upon WB, WA. But what is Na upon WA? But we know molarity is equals to number of moles of solute in 1 kilogram of solute. So this I can consider as WA. So what can we write down this? We can write down this as this, K M of A, molecular mass of A, into, what is it? It's M, molarity. Now you can see the molecular mass of solvent can never be changed. So can we take it as a constant? So now using, instead of these two, I can write down new constant term, that is called Kb, and the Kb is called molar constant elevation. It's called molar elevation constant. What is it called? So particularly I got this value, where this is the rule which we are going to use to find it out. The formula, this formula can be useful for this, and this is called Kb is a new constant. The constant is called boiling elevation constant. It's a boiling elevation constant, or we can call it as a molar elevation constant. Okay guys, and then it is also considered as molar ebuloscopic constant. So this guys, this is very important to understand. This, all the stuff is good for us, and this formula we can utilize for us. So elevation is a boiling point. Elevation in a boiling point depends upon the relative number of moles of solute and solvent, but does not depend upon the nature of solvent, and that's why nature of solute, and that's why delta dB is considered as a colligative property. And now how can I use this formula to find it out, molar mass? So WB, it's upon MB into WA into 1000. This is what the formula I'm going to use to calculate my molar mass of solute, So dear students, this is very important to know, and with the help of this formula I can find it out, molar mass of solute. So MB is equals to what? Then it is K B. Now it's not K only, it's a KB. It's a constant called ebullioscopic constant. It's always different for a different solution at different temperature. Okay, divided by this MB upar gato rayo. Let's keep the delta TB over here in WA. So using this formula, you can easily find it out some examples and answers, which is very easy for us to understand. Let us do one numerical given in our textbook, that is example number 2.7. It says about this. What does it says about? So guys, it's very simple to understand. Okay, from the graph we can easily find it out that delta TB, why it is called a colligative property. So you can make it out from the statement that the formula, it depends upon the relative number of moles of solute and solvent, but does not depend upon the nature of the solvent. Okay, તો સોલ્યુટ નો કયો નેચર છે એની પર ડિપેન્ડ નથી કરતો, નોન વોલેટાઇલ છે કે નહીં એની પર ડિપેન્ડ નથી કરતો. Yes, that's why it is called delta TB. Elevation in a boiling point is a colligative property. So let us do using this formula one example given in our textbook, that is 2.7, example number 2.7. Very nice example given over here. Okay, I'm going to write it down in this manner. Once I will go through the question, I will write down in this way. 18 gram of glucose C6H12O6 is dissolved in a 1 kilogram of water in a saucepan. At what temperature will water boil at 1.013 bar? Okay, so we need to find it at what temperature. Now they are asking about our temperature. It means I'm going to find it out delta TB first. So I'm going to write down equation, the formula which is given to us. It's very simple. You have to make sure all the necessary things are given to us. Okay, in example, in a numerical, it should be given in a question. What is that? It's given number of moles 18 gram. It means WB of glucose is 18 gram of glucose. Okay, molecular mass of glucose will be C6H12O6, which already we are aware it's 180 mole per gram. Okay, dear students, then what about it? Other thing is given that it is given 1 kilogram of saucepan and we are keeping 1000. It means okay, we are well versed about it. It means 1000 kilogram of water is given. 1000 grams. Sorry, it's not a kilogram. 1 kilogram is equal to 1000 grams. So I'm going to keep 1000 over here. And then KB, very nice question. It's a KB is already given. Molar elevation constant. It's a 0.52 Kelvin kilogram per mole. This is the unit of KB. Okay, how does it come? You can easily know that. Now let's find out first delta TB, that is a change in a temperature, and then we can go for it. Now let's substitute the value 0.52. No need to go and follow the reaction, the method given in the textbook. You can use this method. This is very simple and easy to understand method. Can be done in 1000, and what is molecular mass is 180, and into 1000 get cancelled, 180 get cancelled, 10 18 get cancelled. It means the answer is 0.052. This is Kelvin. Why? Because this is given in a Kelvin. Don't worry. Now delta TB જોઈએ. આપણે શું જોઈએ છે? What are they asking about? They are asking about what is the temperature, at what temperature will water boil. હવે water boils કરવા માટે જોઈએ છે એટલે આપણને ટેમ્પરેચર કોનું પૂછ્યું? તો કે વોટરનું પૂછ્યું ને સોલ્યુશનનું પૂછ્યું એટલે સોલ્યુશનનું ટેમ્પરેચર એટલે શું? તો કે આપણને ખબર છે, we know the formula. What is the formula? The delta TB is equals to TB minus T naught B. અને પ્યોર વોટરનું કેલ્વિનમાં કેટલું હોય? તો કહે છે કે આનું 0.052 છે. આ આપણે TB શોધવો છે અને આ શું છે? તો કે આનું છે 373.15 Kelvin. Okay, so this is what it is given. Now you can easily solve it out. TB is equals to what? Okay, 373.15 plus 0.052. Indirectly, if you want, if this given in an MCQ and a delta T is given to you, then guys you can easily make it out કે તમે ડાયરેક્ટલી કરી નાખો. જે પણ બોઇલિંગ પોઈન્ટ આપ્યું હોય પ્યોર સોલ્વેન્ટનું એની અંદર એ ટેમ્પરેચર એડ કરી લો એટલે you get this answer 202. Okay, 10 1 202 Kelvin. This is the answer of your question. So this is the temperature at which When you add 18 gram of glucose in solution, you will get this. Okay, so next session, what we're going to free, we will talk about depression in a freezing point. Thank you.